Okay, so some of the types of questions are ones where if you know the formula, you just plug the formula in, and that would be sort of the easiest way to answer the question. So, and this is one of them. When you're solving linear equations with two variables, the expectation is that you can go ahead and grab a packet there on the table, and you can check off next to your name. And so if you're familiar with the formula, you can just go ahead and take that slope equation. The slope is what we see right here in sort of the notes for this. The slope, if you have 2 points, it's the difference of the y's. So here 8 minus a negative 5 is the difference of your y coordinates over the difference of the corresponding x's. So we started with the 8, so we'll begin with 10 minus the other x coordinate 4, minus minus. When you subtract, you are adding the opposite. And so you wind up getting 13 over 10 minus 4, which is 6. And so your answer would be 13 over 6. Now, if you forget this formula, or if you have time and you want to go back and you want to verify it using the Desmos calculator, you can go in, you have 2 points, so you can actually write the whole equation of this line. So if you were to, if you were to hit this add item symbol and choose table, you can select the 2 given points that they have, 10, 8, and 4, negative 5. Enter that in your table. And then you can access the linear regression by hitting Y1. Similar to, remember the similar to in the keypad right here. If you click on the letters, it's this button down at the bottom, this similar to symbol. M times x1 plus b, that's the format. And notice you have your slope and your y-intercept. Since this is a slope, you could enter it as a decimal, or if you want to find the rational form, the fraction form, slope is the m. So if you access or pull the value of m and hit this fraction key, it'll show you the fraction form of it, which confirms 13 over 6. All right, so try that same thing with the next odd problem here, 17. See if you can answer that question. Again, by hand or calculator. Anytime you have problems with these other unknowns, so these other variables that represent constants in here, a lot of times that just kind of indicates that it's a slightly more challenging type of question. Okay, but a lot of them, if you just kind of take your time, see the approach, you can always just assign a value to your variable. So we could let n be any number, and then just plug that in and see which of the answer choices works if we plug that same number in for the n on the answer choices, as well as the table of values. But really what we're looking at in this problem here is if you're doing this by hand, it's the understanding that the difference of y's is just the change in y. So delta y means the change in y's over the change in the corresponding x's. And so if we move either from top down or bottom up, so to me I'm going to move from the bottom up because it's easier to see the change that's happening. So if I take the change in y as I move up here, I go from n to n plus 84. So what is the change? The slope is the y's, I'm adding 84. And at the same time, what am I doing with my x's? Since I was going from bottom up, my x's go from 0 to negative 5, which is a change of minus 5. So there's my answer, negative 84 fifths, and that would give me my solution. So if I'm solving this by hand, that's the process that I'm using, the thought process. You can enter this, because it's a linear equation, okay, right here, a linear relationship, you can enter this in a table, and you can find the line of best fit, the linear regression. And you can even leave those variables in. So I can say n plus 168. I can take negative 5 and n plus 84. And I don't necessarily need all 3 points. I just need 2, but I'm going to go ahead and put the third one as well. And if I enter those into a table, I can still call out my linear regression. So y1 is similar to mx1 plus b. Again, make sure that you put your subscripted ones. And I do need to assign a value. Again, just by giving n a value to start with and giving it that slider, I can now see what my values are as n changes. So again, n can be anything. So let's just look and see, what is it if n is 2, right? So I see that my slope is negative 16.8. I want to see what that is as a fraction. So I'm going to access m, put it in fraction form. I see it's negative 84 over 5. That is one of the answer choices, but what happens is this changes. Notice that the slope doesn't change at all. The slope stays the same, and so that tells me visually that a negative 84 over 5 is in fact the slope of that line. Right? Even no matter what n is, that's going to be your slope. Again, I strongly recommend that when you guys do practice versions of this digital SAT that you use the Desmos calculator. See what it does. Again, if you have a TI-89 and you're comfortable using that, it should be pretty powerful in there as well. I focus mostly on Desmos here because not everyone has the TI-89s or knows how to use them, and sometimes it takes longer to learn that. But if you're familiar with TI-89, it's not a bad way to go as well. All right, if we jump to the next slide, we're still working with linear equations in the two variables, but this is, notice I haven't described this or talked about it, but next to each of the titles here for each question, I put where the content area it's coming from, but I also put whether it's considered a hard, easy, or medium problem. So the H's, these would be the ones that would be considered a little harder or that more students struggle with. And so I want you to try question 19 here. Again, I provide some notes about slopes versus slope of parallel and perpendicular lines. I'll talk about it briefly before we do the problem, but that's the information that this question is based off. All right, so I'm going to go ahead and talk through this. Again, this is one where if you understand the relationships, when you find the slope of a line, any line parallel to that is going to have the exact same slope. So if the original slope is a over b, then that means the slope of a parallel line will also be a over b. Okay? And if you find the slope of a perpendicular is going to have a slope that is the negative reciprocal. So change the sign, flip the fraction. If you are working through finding the slopes, what you can do, probably the easiest thing to do by hand would be just rewrite this in its slope-intercept form. And so if we take this equation, 8y plus 24x equals 3, and we solve for y. Okay, so that means we subtract 24x from both sides, and then divide every term by 8. And when we do that, we get our slope to be negative 3x, or negative 3, and we get our y-intercept to be 3/8. And so this is our slope. The slope is this coefficient of x, which means the slope of, they're asking for a perpendicular line here. We're going to flip the fraction to 1/3, change the sign from a negative to a positive, and so positive 1/3 becomes your answer. Now, if you are uncertain, like if you're struggling or you don't remember how to find that slope, what you could do is you could type this equation in. I'm not even going to go that direction, because in order to type it, you would have to solve for y anyway. So once you solve for y, you can find the slope of your equation from that. So doing that problem by hand is probably your best bet to answer it. All right, so if we continue to kind of scroll through here, now we're going to talk about linear functions. Okay, so linear functions have this function notation, and there's a couple things that you should be familiar with regarding function notation. First, remember, function notation looks like this, f of x. It's usually letters in the middle of the alphabet, so f, g, h of x. And it's just another way of writing the output of an equation, okay, that is a function. And so f of x is equivalent to y. And what that means is if you have an equation set up like this, the ordered pair, whatever x the input is going to yield the y value. So you can take a function notation and you can convert it into ordered pair by looking at the input and the output. Now, for the question that we're going to do, that's not part of this question, but it does come into play for functions on the SAT. Okay, so I want you to try question 21. Again, see if you can answer that, how you would answer it, and I'll give you a couple examples of what you could do. The instinct for this question would be, or here's what I was talking about earlier. So they give you a function notation. J of 14 is equal to 29. That means that 1429 is a solution point. So that is that's a point that exists on here. So what we know is if we substitute in 14 for x and 29 for our output, we would get 29 is equal to m times 14 plus 204. So we can use that to solve for our slope. So here if we subtract 204 from both sides, and so I'll just use this as a calculator. So 29 minus 204, I get negative 175 is equal to 14m. Divide by 14. So negative 175 divided by 14. If I want to see what the fraction form is in reduced form, I can. So I get negative 25 over 2 is my slope. Once I find this slope, what I can now do is I can rewrite my equation. My equation is negative 25 halves times x plus 204. And I can now evaluate j of 8. When I evaluate j of 8, that means I'm taking that function. I'm going to rewrite my answer up here. So I'm taking my j function, which is negative 25 over 2 times x plus 204. So whatever is inside my parentheses, I'm going to multiply or plug in for my x. 2 goes into 8, 4. 4 times negative 25 is negative 100. Negative 100 plus 204 gives me my answer of positive 104. And so that would be the value of j of 8. All right. There's a couple other ways that you can kind of incorporate this using the capabilities of Desmos to find this. Okay, let's look at one of them. I'm going to use j of x since that's what they used. It's not a big deal what you give your variable. Notice I'm just going to copy the equation in. M prompts me to create a slider. I can either hit enter and it'll automatically build it, or I can just click that button or hit m equals something. I'll come back to m here in a second, because what I want to do is I want to find what value of m is going to give me this function where j of 14 is equal to 29. So what I could do is if I put j of 14 here, what I see is if m is 1, my answer is 218. So I'm going to scroll. As I scroll to the right, it gets bigger, but I need it to get smaller, right? I need it to equal 29. So I'm just going to slide this until I see 29 show up for j of 14. Notice I ran out of room. Negative 10 is the lowest I go. So if you click on negative 10, we can make this smaller. I'm going to just put it at negative 20 right now because I feel like I'm pretty close to getting 29 here. Keep going, and what I see, there's 29. And so this gives me my slope. At negative 12.5, that is the slope. And so once I get my slope to be what I know it has to be, based on the given information, I'm now going to type j of 8 in another line, and that's going to give me my answer, 104. Okay, so this allows me to do it without having to do any calculations, just understanding sort of how the calculator works with that. Okay? All right. Again, if you have any questions on anything that I'm going through, please feel free to ask. If you solved it a different way and it worked, it's probably good. If you want to ask me, again, either in front of everybody or on your own to check your work, I'm happy to. But if it works, the methods that I'm using aren't the only methods that you can possibly use. All right, so I want you to try this problem on the next slide, dealing with linear functions again. So what you're going to see here, and again, I have notes on each of these slides that are relevant to those types of questions. And so these ones, there's no calculation. So a lot of times with linear functions and even quadratic functions, they're going to basically ask you questions that are prompting you to interpret the information they provide. Okay, so a reminder that linear equations are y equals mx plus b. Because we're in functions now, instead of y, they'll often be f of x. Okay, where you have your slope. Slope is a rate of change, or it's units, units per whatever the input is. So it could be it could be a rate like meters per second, but it could also be videos per hour or whatever. It could be some other unit. The b is our y-intercept, and that's usually the initial amount, or it's some constant value that's assigned first. So if you're charged like a set fee and then an hourly rate after that, that would be, the set fee would be your y-intercept. Okay, so if I just look at this function right here, okay, what I see is that w is a function of t, which generally refers to time, and it's equal to 400 minus 10 times t. What that means is you're starting with 400 units of something, and every t units you're losing 10. Okay? And so if it asks you here, this is liquid draining from a hole, okay? And so what's the predicted volume draining from this container each second? So this is a rate of change, right? How is this volume changing? And so you see right here, it's changing 10 units per second, and it's in the negative value, so it is draining at 10 units per. It's just, again, a matter of identifying what the elements of that linear function mean. Okay, so you'll see different variations of these. Really quickly, let me go back, talk about the kind of website here, the classroom site. So if you go into this classroom site, I mentioned before, some of you weren't here, on this Canvas page, everything in this left column are practice problems. Okay, so if you want to do practice problems here, you can. Well, if you scroll all the way to the bottom here, it says digital practice. So if you wanted, let's say, to practice more questions like what 23 is, okay, the question that we just did, if you want to practice questions that are like that, you can click here, go to question 23, and there's it's like a pool of questions that are similar to it, or it'll give you different versions, and that can be true anytime you're doing a question here. So like if we wanted, let's say, to see a question similar to 23, we can go into that, and if we jump all the way to question 23, it's going to be a question that is a function that's asking you to interpret the information. So you can do some different practice there, as much or as little as you want, just looking at the questions that are similar to the ones that we're doing. They won't always be the exact same, but they should be the similar content areas. All right, so let's go ahead and jump to 25, still working with linear functions. This time, though, it's asking you not to interpret it, but to find information regarding the linear equation itself. I haven't specifically talked that much about it in the example problems, and it's not as clear a useful strategy as it used to be. But scanning the answer choices will often kind of give you an idea of what content area you're testing. So like if you scan the answer choices here, you see they're all linear functions. So that gives you kind of a little bit of idea of what you're being asked to do. So it'll have something to do with rate of change or slope, have to do with y-intercepts or the initial amounts. And so when you go into this problem here, you see that function notation written again, where it tells you f of x equals y corresponds to the ordered pair x, y. So here you see that an input of 0 leads to an output of 10. An input of 1 leads to an output of 14. In reality, because of the answer choices, if you scan them, you will see there's only one possible answer that could be right here based solely on this point. This is a y-intercept, right? The y-intercept is the value of y when x is 0. So that means if we look at the equations that have a y-intercept of 10, you know your answer has to be this third option. Okay? Now, if you don't see it this way, you can still use linear regression, and you can actually find the equation and confirm that this is in fact correct. And so if we were to take these 2 points right here, plug them in to Desmos and run a linear regression. So again, 0, 10, and 1, 14. We can call out the equation by hitting y1 is similar to mx1 plus b. Again, remember to use those subscripts. It'll automatically subscript when you type the number after the x and the y. And you see your equation is here, 4x plus 10. And that would confirm that that is in fact the correct answer. Right, so you can still use the calculator if you want to, but if you catch that right away, it'll save you a little bit of time. All right. The last type of problem that or actually, I guess there's inequalities too, but the next type of problem that we're going to look at has to do with systems of equations. Okay, so I want you to see if you can solve this system right here, question 27. So there's several different types of systems of equations that you're going to see. There's a type that says solve for x, solve for y, solve for the ordered pair or the intersection point. If that's the case, then using Desmos, like straight away, probably the best method to solve it. But anytime you're being asked to solve like a combination of terms, so here x plus y, or if you look at the one below, 2x. If you're asked to find something that's not just the x or just the y, more than likely, and the SAT has been doing this for many, many years, is that you can take the given system of equations, and if you just directly combine them, so either add straight down like terms, subtract the equations from each other directly, you're going to end up with that exact form of the expression. So if I look at this equation, or this system right here, if I just straight add down the column of like terms, so 7x plus a negative 6 gives me 1x. 0 plus a y gives me y. 63 plus a negative 49 gives me 14. And that is my solution. X plus y, it gives you the direct solution to it. And you don't even have to plug any values in or anything of that nature. And now, you can still solve this by entering your questions, or entering your 2 equations as a system. So if we entered 7x equals 3, and then we entered negative 6x plus y equals negative 49, we can go into our graph and see where they intersect. They intersect right here. We have 9 and 5. If you are going to solve it this way, just make sure you're very careful. Our points are 9 and 5. X is 9 plus 5 gives us our solution 14. Okay, oftentimes, the values that you would get, or the values that make up the individual parts, will often be distractors. So there's a likelihood that 9 and 5 would show up as one of the distractor values. So be aware of that, or be careful with that. All right, so let me talk really quickly once again about when you are working through the problems on the practice. Anytime you do an individual question on the MyOpenMath practice, if you get it right or wrong, you're going to be prompted to try a similar question. So like if you are looking to answer these questions like the ones that we're doing right now, 27 and 28, if you answer a question right, but you want to try a similar one, if you just hit get similar question, it may give you the same version of that, or it may give you a slightly altered version, but it comes from a pool of questions. So here, if you look at this problem right here, and notice the strategy is you want to solve for 10x. Well, if you have y equals 4x, I'm going to rewrite it. 4x is equal to y. And then I have 6x, or actually, let me rewrite this here. I'll take my equation 6x plus y equals 30, and I have y equals 4x. Well, if I put my 4x on this side equals y, and then I subtract y from both sides, what I see when I combine straight down my columns is that 10x, the y's cancel, is equal to 30. And so that gives me my answer again, very directly. You don't have to do the whole system to solve it. You can just combine your equations directly. Okay, so be aware of that. Again, that's a common strategy that SAT uses for their questions. All right. The next one, the next questions, or the next two questions here, have to do with this relationship that when you have a system of equations, again, there's three possibilities. It is possible that the two lines that you're working with are parallel lines. If this is the case, then there will be no solution. And so if lines are parallel, there's no solution. So if you compare the slopes. Right? If their slopes are exactly the same, then it means no solution. And you can also have a situation where two lines have infinitely many solutions. If that's the case, what's going to happen is one line is going to be completely superimposed on the other line. It's just two different ways of writing the same line. They're two equations that mean the exact same thing. If that's the case, that means there's infinitely many solutions. And when you're solving for this, if two equations are exactly the same, the left side of the equation and the right side of the equation are going to be identical. Okay, so you can manipulate one or both equations and you get the exact same equation for each of those the two in the system. And then the final situation is kind of what we will normally see, which is two lines intersecting. So they'll have one point. If that's the case, then it'll when you are solving the equation, you can actually find x is equal to some numerical value, and that will be your answer. Okay, so see if you can take this first question. It tells you here that there's no solution. So that means you're dealing with parallel lines. Can you find what the value of t would have to be for those lines, that system, to have no solution? How many of you are solving by hand and finding the slopes? Is anybody typing these into Desmos and trying to line up the graphs? Okay. I'll show you both of those. They're both valid strategies. All right. More than likely, if I'm looking at this question, I'm seeing no solution means parallel lines, so I want the slope. I'm going to find slopes and set them equal. So to find slopes means to put each one of these into the y equals mx plus b form and compare the slopes. So if I take my top equation, I combine all my like terms, so move y's to one side. So I'm going to add 8y, giving me 15y. I'm then going to subtract 1 from both sides. I have 10x minus 1. And then I'm going to divide every term by 15. And that's going to give me my slope. I'm not even going to simplify it here. I see my slope is 10 over 15. I can reduce it if I want to, but I'm just putting it into this form, finding y. Now I'm going to do the same thing with my second equation here. If I want to solve for y, I would divide each term by t. Well, dividing by t is like multiplying each term by 1 over t, right? So because if I tried to take this fraction and divide by t, it maybe doesn't look like, or it's harder to see what you're actually doing, but really what I'm doing is I'm multiplying by 1 over t. So that's going to give me the equation y equals, here I have 5 over t x plus 1 over 5t. So when I look at how that's formed, all I need to do is compare my slopes. So I'm looking at this and this. Okay, so I'm going to take 10 over 15, and that is equivalent to 5 over t, and I'm going to solve the resulting equation. Now, again, however you want to solve this, I'm just going to cross multiply. 10 times t is equal to 15 times 5. I'm not multiplying them out yet. I'm just going to leave them as factors, divide both sides by 10, and that's my t value. And now I'm going to start to cancel. So 5 goes into 10, leaving 2, and I get my answer to be 15 halves. Okay. And so there is my solution for that problem. So if I'm solving it by hand, that's what I'm looking at. All right, let's take a look at what happens if you solve by using the graphing calculator. So we have 10x minus 8y. I'm simply going to type in the equation that they gave me. So here's my line. Okay, and then I'm going to type my next equation in. So t times y equals 1 over 5, and that's plus 5x. Okay, now I do need to add a slider, right? Because I don't know what t is, but I want these to be no solution. I need these two lines to be parallel. So as I start to rotate this, I'm going to see they're getting closer and closer to parallel here. Now they go past parallel. So I'm going to zoom in, okay, and I'm going to just slide this, and now notice here they are parallel. Okay, and so just by visually finding where those are parallel lines, I now have my solution. T is 7.5. If I wanted to find the rational form of that, I can type t and hit the fraction form. 15 halves, it confirms that. So again, one of the issues that we tend to have, or a lot of students here tend to have, is by the time we take our SAT, a lot of us are so far removed from the content area that's being covered on it that sometimes like you have like the more complex ways to solve things. So if you compared the two ways that we just solved this, right? The graphing calculator one, super fast. Didn't take much thought other than knowing like how the graphing calculator works and like what information it can provide. Okay, so trust whatever you need to trust. Okay, again, it's the new SAT is designed so they're hoping that time's not a major issue. Okay, so you can trust your calculation. If you're going to use calculations, even if you wind up using derivatives to answer a question, that's still fine. Okay, but know that if you can practice some of the simpler things for solving, like anything you can solve visually, might save you a ton of time if you have an idea on what you're looking for. Okay. All right, let's try the next question here on this slide, the next odd question, 31. Okay, so this is solving a system, but it's a system that you have to create yourself, and then you can solve it. So you have to. It doesn't just give you the equations to use. Right. So the way that the problem is set up, it says a group of 232 people went on an overnight camping trip. So that that's the total amount. There's 90 tents with them. Some tents hold 2 people, and some hold 3. Okay, so first thing is you have to kind of give yourself some variables, right? So let's call X the number of tents that hold 2 people, and Y the number of tents that hold 3 people. So we know that there's a total of 90 tents. So we know that X plus Y has to equal 90 total. Okay, and then we know that the total number of people is 232. Well, that means for every 2-person tent, we have to count 2 people, and for every 3-person tent, we have to count 3 people. So here is the system that we create. So in this problem, you do need to create the system on your own first, and now you can solve it any of the ways that you want. Again, with the Desmos calculator being embedded in the test itself, I would just plug this in, my 2 equations, x plus y equals 90, and then 2x plus 3y equals 232. I do need to zoom out to see where these intersect. I just need to click on one of them, and I see 3852 is my answer. So 3852. I'm looking for the 2-person tents, which I was establishing as my x, and so 38 is my answer. Now notice that one of my distractors is the y value. Okay? Very likely going to happen. Okay? So if you see a distractor that's one of the other parts of your answer, 2 things. 1, it probably means you did it right. 2, double check to make sure that you're finding the correct piece that it's asking for. Okay, so the worst thing would be to do all of this right and then answer 52 because you kind of made a mistake, okay, and you inadvertently answered the wrong element. You answered the 3-person tent instead of the 2-person one. If you were solving this by hand, the way that you would solve this, since you're solving for x, the 2% tent, what you would do is take this equation, solve it for y, so 90 minus x, and then you'd plug that into your second equation for y. So if we substituted in 90 minus x for that y and solved, what we can do here is we would get 2x, distribute the 3, plus 270 minus 3x, and then combine your terms. So negative 3 plus 2 is a negative x. Subtract 270 from both sides. Oops. And you would get negative 38. Change the sign. You could still get your answer, okay, but use the system that's available. Do it the easiest way possible. That's the most efficient way is definitely my recommendation. All right, let's see if we can finish. There's 2 more questions in the content area for algebra, so let's try to finish those and then we'll end for the day. So try 33, this next question. Now we're looking at the content area of linear inequalities. Not really like a formula that you've learned that that you would apply to solve this, other than sort of the intuitive nature of, if you know that parking space is between 8 feet and 9 feet. Okay, so you know that a space is somewhere in that range. And if you have a curb that's 144 feet long, so here's 144. What you want to do is figure out how many 8-foot spaces would there be available and how many 9-foot spaces would there be available. And that's going to give you like your maximum and your minimum number of parking spaces. Now, the one thing with this is it might be a little counterintuitive, so you want to think about it. So which of these are going to yield more parking spaces, the smaller spot or the bigger spot? Yeah, the smaller one, right? So we know that the upper limit of this is going to be 144 over 8. The lower limit is going to be 144 over 9. And so if we do those 2 calculations, we see that there can be 16 parking spots if we make each one 9 feet, and there can be 18 if we make them 8 feet. And so somewhere between 16 and 18 has to be the number of parking spaces that are available. So again, this one isn't based on a formula that we've talked about in any of your math classes. It's just based on sort of the intuition of inequalities and the sizes for those. All right, the last question that we're going to talk about here today in the algebra section, see if you can answer this, and it's a system of inequalities, which also are very likely to occur. So as you're prepping for this test, do realize, and those of you who are juniors might already start to be thinking about it, there are a number of colleges that offer free money, free scholarships that you don't even have to apply for, that you just qualify for and get if you have a certain GPA and a certain SAT score. U of O is one of them, and I think theirs is, for one of them, it's like $4,000 a year. The other one is like $6,000 or $8,000. So you're talking like, I mean, you're talking $24,000 that is available depending on your scores. Okay, so don't let sort of pride get in the way. Okay, to use a calculator, like to use this this calculator that they put into this test to your advantage is a huge opportunity. Okay, take advantage of it, learn how to use it. Don't think that like you shouldn't use it because you can do it by hand. Because if you're going to solve this problem by hand, you're testing each of those individual points. And it's a cumbersome thing unless you get the right answer early on. But if you type this into the inequality, now notice when I hit less than and then equal, it creates that symbol for me. That's also available in the keyboard as well. So you can just enter the less than or equal to x plus 7. The graphing system will do inequalities as well. So y is greater than or equal to negative 4x plus 2. And so what I can do here is we can zoom in. The solution set to this is going to be everything, or any point that's in this double shaded area, the part that's both black and red in here. Okay, and so which point is a solution to this? Well, if we just plot those points, so if we just type this in 16, 0, and we look for that. And we can zoom out here. Here's 16.0. If you want to label it to see exactly where it is, if you don't see it from the points, you can. Is that point in the solution? Yeah. So we happen to find it on the very first one. But if you test any of the others, so if I test negative 16.0, I see that it's not in either of them. If I test 0.16, I see that that's only in the red shaded region. And if I test 0, negative 16, it's only in the black region. So use the graph, get familiar with it, take advantage of it. Is my, it's like one of the biggest takeaways from this course that you can walk away from. Start practicing with that calculator, see what you can do and how quickly you can do it.